All right, ladies and gentlemen, we have a wonderful special guest here, Mr. Odar Sizanko, pronounced Ordachenko.
What's going on, guys?
Ooh, yeah. Two of us. Two for the price of one. Math videos. America. All right. So we're going to be talking about Venn diagrams. Not just for organizing your thoughts and feelings and other things in other classes, but we're going to math it up with them too. All right, so we've got this lovely little diagram here, and it says here, considering all the people in the world, let A be the set of Americans, America, citizens of the United States, and let B be the set of people who have brothers. So like, not like Hulk Hogan brother, but like actual brothers, okay? All righty, so this outer rectangle, if you will, that's just considered to be like all the peeps in the world, right? All the world, all the world. A is the Americans, and B would be people with brothers. But as you see, there are some people that are Americans and have brothers. That right there is the intersection of the two, the shaded region right in here, okay? So I myself would fall in here as I am a proud American, and I have a brother.
I would fall in that category as well.
Mr. Ordachenko would also, all right? So how do we represent this population using symbols? Well, if we're talking about Americans, we would just write A. Cool? If we're talking about people with brothers, we would just use B. If we're talking about people that have that are Americans and brothers, you would do A intersection B. Wonderful. That N looking thing or upside down U is what we do to represent the and. Those two things. All right. Now, if we were just saying like, hey, you're American or you have a brother, you'd use the U looking one that's saying or. Awesome. Now we're also going to dive into some probability. So the only difference when notating probability is we put a P in front of it. So he said, what's the probability of being American? That's how that reads right there. And we can use the same notation for probability of having a brother, the intersection of the two, or the or statement that we had. We can just throw a P in parentheses around them. Lovely. All right, so this next one here is the entire two circles of our Venn diagram shaded, right? This is saying people that are Americans or have brothers. And we actually talked about this in the last slide. How would we write this set? We would say A or B. Either one of those suffices. You can be an American without a brother. You can have a brother and not be American, or you can also be American and have a brother. Cool? So that's what this population represents. A person that is American or has a brother, or it could be both. All right, here. So now we got a whole different, shaded dealio, but with the same type of Venn diagram. So what does this picture represent? Well, this picture is representing basically everybody that's not an American. So how do we notate that? We would notate that as either A prime or A with a little c. Either way, we're talking about the complement. Basically everything that's not that. So if we were talking probabilities, you'd write it out as what's the probability that someone is not an American? And in that case, we would have like little values in each one of these of the probabilities, like, oh, it's a 0.5 chance that it's this, it's a 0.2 chance that it's this, so on and so forth. All right? Now here it says, are these two events independent or dependent? So all we're thinking about with that is like, well, does one affect the other? Okay, so, well, being an American doesn't necessarily affect whether or not you have a brother, right? So these two would be independent, okay? Or whether or not you're a brother doesn't affect if you're an American, right? It doesn't have necessarily a direct effect with each other. So they are independent of each other. Now what is a sample space? Well, the sample space is everything or all the people in the world. Cool? And there we go, independent for this one. All right, so now let's think about cars available at a dealership. Woo! Going car shopping. I don't know where we're going to go, but either way, we're going to be car shopping. Suppose a car is selected at random from the cars at this dealership. That's a crazy idea, but whatever. Let the event that the car has a manual transmission be denoted by M, and let the event that the car is a sedan be denoted by S. The Venn diagram shows the probabilities associated with the four regions of the diagram. So, our big old rectangle, that is representing all the cars at the dealership, also referred to as, Mr. Odachenko?
The universal set.
The universal set. Not Universal Studios, but the universal set.
Warner Brothers fan.
Yes. All right. M, that's our manual transmissions. S, those are sedans. And what do you think that middle area is right here with the probability of 0.12? That would be a sedan that has a manual transmission. All right. So those are our probabilities. Now, what do you notice about all of these probabilities? Well, you might not notice it without a calculator, but all four of those add up to 1, right? 100%, basically. Cool? So these all are all decimals rather than percents, all right? So we're writing them as decimals. That all adds up to a total of 1. Yay! Cool. So if I said, what's the probability of selecting a manual car? Well, a manual car has a probability of 0.09, but a manual sedan has a probability of 0.12. Therefore, I have a total probability of 0.21. That would be my probability of selecting a manual car. It might be a sedan, it might not be. We don't know. Well, what's my probability of selecting a sedan? Same kind of thought process. I would take my 0.6 and my 0.12 and get 0.72. That would be my probability of a sedan. What's my probability of both being manual and a sedan? So M intersect S, M and S, right? Manual and sedan. That would be my 0.12. No adding or subtracting there. How lovely. All right, now what about, and I'm gonna give myself a little more room here, right? Zoom that bad boy out. What's the probability of a manual or a sedan? Well, the manual or a sedan, basically, I could just add those three numbers up of 0.09, 0.12, and 0.6. All right? And that leaves me with 0.81 as my probability of either one of those. Another way I could have written that is everything, well, I could take the complement of that 0.19, right? I'm not even going to write that out. But you could take the 0.19, which is all the other cars at the dealership, right? That's what this is saying right here, is everything but a manual and a sedan. If you took 1 minus 0.19, that would get me the 0.81, okay? Now, you do have to be careful about how you are calculating some of these things. It's not every time that we list them out as this, and that, like in the separate areas. So there's times where I might be like, well, here's the probability of this whole piece right here and this whole piece, and I give you the middle part. So when calculating the and statement, sometimes you have to subtract out that middle part. So you just have to pay attention to the information that's given to you. Well, I hope you guys enjoyed probability with Mr. Allen and Mr. Odachenko here, and I hope you have a wonderful America Freedom Rock and Roll Day and full of Costco samples and things like that. Right, Mr. Odachenko?
Absolutely right. Have a great day.
Mm-hmm.